Hey, what's going on, guys? Let's see how we can do this problem right here. The question is asking to find the current through these three resistors, and here we are going to use the Kirchhoff law, right? So let's see how we can apply the Kirchhoff rule and find this one. So the Kirchhoff's first law says the current entering should be current leaving. So that's going to be we can write it like this: sigma I entering is equal to sigma I leaving. So we can say I naught, right? So here let's say we have a current passing through this one, this resistance I1, and one in this direction I2. So we just assume the direction, right? It doesn't matter which direction you choose. If you choose the wrong direction, that's going to give you negative answer. So that's the thing. And since this is positive, we can just assume this direction, and let's see whether we get positive answer or negative answer, right? So here we have I entering should be equal to I exiting. So if you take this node right here, so let's choose a different color. If I take this node, this I1 should be equal to I3 and I2, right? This is entering and that should be equal to exiting. So we can say I1 is equal to I2 plus I3. So this is one of the one equation. Let's see how we can use the second law and create the equation. In the second law, it says when the voltage in a loop add up to 0. If you take a voltage, total voltage in a loop, that's going to be add up to 0. That's the second law of the Kirchhoff. Right. So let's write that one. So we have sigma loop add up to 0. So let's see how we can create the equation based on that. So let's take this one as our loop, this location, and if it's going, if you take a loop in this direction, and if the voltage is along the direction of the current, that's going to be negative because we are going to have a voltage drop. So we are going to have negative. If it's opposite to the current direction, we are going to have positive. So here if I take this loop 1, and this is going to go through this, and if I take, I'm starting from this node right here, so it's going to go through this, and this is also going to go through this. That's going to be loop 2. So I'm going to start from this one and add all the voltage. So first we have I1 8. We know that V is equal to IR, right? V is equal to IR. So first create the equation. So first one is also we have 30 voltage in the battery. So that is 30 minus, because it's going along the current's direction, so it's minus. So this is going to be 80, not 80, 8 I1. 8 I1. Then again, if you come back like this, current's direction, so that's going to be negative. So this is going to be 3 I2 is equal to 0. So this is for loop 1. So this is our, let's say this is second equation. Let's apply this one to loop 2. So I'm starting from here, going in this direction. So this is against the current. So this is going to be positive. Current is down direction, I'm going in this way. So it's against the current. So we are going to have 3 I2, that's positive. And then if I go through this, it's along with the current direction, negative. Minus 6 I3, that's equal to 0, right? This is our third equation. Now we have created the equation. Now all we have to do is simply plug and find the answers, like rearrange them and find the answers. So here what we can do is we can take this I1 and you know what, instead of this 8 I1, if I grab this equation 2, we have this one right here. So let's write that one here. So it is 30 minus 8 I1 minus 3 I2 is equal to 0. and we know that I1 is equal to I2 plus I3, so we can plug that one instead of this I1. So this is going to be 30 minus 8 I2 plus I3 equal to 0. You can use any method you want to solve for I2, I3, I1. All you have to do is get the final answer, right? So this is one of the method. So let's go ahead and solve it. And also we have minus 3I2 minus 3I2 is equal to 0. So let's solve this one. This is going to be 30 minus 8I2 and then plus 8I3, right? Plus 8I3 minus 8I2 is equal to 0. Now let's bring this one to other side. So here we are going to have this 3. 8 plus 3, 11 I2 plus 8 I3, and if I bring the negative to the other side, that's going to be, 30 to the other side, this is going to be negative 30. So this is, we are going to have 11 I2 plus 8 I3 is equal to negative 30. So this is one of the equation. It seems like there's a mistake right here. Let's figure it out. So minus 8 times I2 minus 8 I2 minus 8 times I3. So this should be minus 8 I3. So this is minus 8 I3. Then we have minus 8. This would be also minus right here. So we can convert everything into plus by multiplying everything by minus 1. So this is going to be 11 I2 plus 8 I3 is equal to 30. So the reason I changed in this pattern is because we have this equation in I2 and I3. So we can do something with this. So let's bring the equation 3. Equation 3, that is 3I2 minus 6I3, right? That's equal to 0. And if you see, if you multiply this one by 4, you will get minus 24. If you multiply this one by 3, you will get plus 24. So then when we add them, we can get rid of this I3 and find I2, right? So let's multiply this one by 3. So this is, let's multiply by 3 and let's multiply this one by 4 and see what we get. So here I'm going to continue right here. So if I multiply this one by 3, this is going to be 33 I2 plus 24 I3. I'm continuing this one right here. 24 I3 is equal to 90. And then if I multiply this one by 4, this is going to give us 12 I2 minus 24 I3 is equal to 0. So from this one we can get rid of this one. This is going to give us 45 I2 is equal to 90. Therefore I2 is going to be equal to 2 ampere, right? So we found out I2. Now let's see how we can figure out I1 and I3. So to find the since we have I2 right here, we can apply that one in this equation to find the I3, right? We know that from this one, we know that 3I2 is equal to 6I3. 3I2 is equal to 6I3. Therefore, I2 is going to be equal to 6 divided by 3. That's going to be 2I3. So from this one, we know that, we are trying to find I3 right here. We already know the I2. So I3 is going to be 3I2 divided by 6. That's going to be I2 divided by 2. I2 divided by 2. That gives us I2 is 2 ampere divided by 2. That's going to be 1 ampere. So I3 is going to be equal to 1 ampere. Now we have I3. To find the I1, we just have to plug in this equation. So if you plug that one in this equation, this is going to be I1 is equal to 1 plus 2. That's going to give us 3 ampere. And these are the 3 I values. The question is asking I through the 3 resistors. In I1 it's 3 ampere. Here 3 ampere. And in I2 we have 2 ampere. And in I3 we have 1 ampere. Since the answers are positive, this is going to be the exact direction of the current, right? If we get the answer negative, it means it's acting in the opposite direction. And that's how we do these kind of problems. I hope you guys find this video helpful. See you next time.